let's see. Mode. So in continuous probability distribution, we use fx to sketch the graph. So once you sketch the graph already, mode is the highest point in the graph. Highest point in the graph. Okay, so at most of the time, you can easily find the highest point of the graph by using the differentiation concept, where maximum point in differentiation, it means dy dx equal to 0. Dy dx equal to 0, you find the x, then the x is the mode. Okay, so sometimes our graph is not having the maximum point in this way, then the way to find mode is a little bit different. Okay, I give you an example. Let's say how to find mode, which is the maximum point. Okay, I start with a simple example how we find mode. Okay, so let's say we set out a function here, fx equal to x kx x minus 4, 0 or otherwise, and this is for the interval from 0 to 4. Okay, so in order to find the mode, we need to find the values of k first. As we know, integrate from the smallest x to the greatest x is equal to 1. Okay, so for this case, integrate from 0 to 4. I expand the function at the same time, kx squared minus 4kx. Okay, so then I integrate that, kx squared minus 4kx dx equal to 1. So become kx cubed over 3 minus 4kx squared over 2, 0, 4 equal to 1. So then we substitute 4 inside. 4 to the power of 3, 64. 64k over 3 minus 64 over 2, 32k. When I substitute 0 into x, both terms become 0. So then equal to 1 straight away. Now 64 over 3 minus 32, I get negative 32 over 3k equal to 1. Okay, then I get k equal to negative 3 over 32. Okay, so once I get the values of k, now the functions will look like this. Fx equal to negative 3 over 32x, x minus 4. The interval for x is 0 to 4, 0 for otherwise. Okay, so now we want to look for the mode. Okay, so first I'm going to sketch the graph so that you can understand the process of finding the modes easily. Okay, so I sketch the graph. So from here we know that the roots are 0 and 4. Okay, 0 and 4. And from the negative value, you know, when you expand this, you will get negative 3 over 32 x squared plus 3 over 8x. So because this is negative, so you should expect this to be a set face graph. So a set face graph to be like this. Now we know that when the fx is the maximum, then the mode is there. So the mode is here. So in order to find this, we need to find out the stationary point. Okay, so we take fx equal to negative 3 over 32 x squared plus 3 over 8x. We differentiate this. Negative 3 over 16x plus 3 over 8. We let f prime of x equal to 0 in order to find a stationary point. Then we get 3 over 16x equal to 3 over 8. Then we get x equal to 2. And hence the mode is equal to 2. Okay, so that is how we find mode. In general, remember the steps. What we need to do is we sketch out the graph. Okay, we sketch out the graph to see whether there is a maximum point or not. Okay, so sketch the graph. So if there is a maximum point, we do differentiation, and then we let the derivative equal to 0, and then we find x. So the x is the mode. So in general, we do it in this way, 3 steps. Okay, so let's say you have a continuous graph like this, and you want to find the mode. The mode is actually here. The x value is the mode. So I don't know what function should I take, so I just put it in general, y equal to fx. Okay, y equal to fx is the function. Okay, now what to do is y equal to fx. You can use graphic calculator. Whatever function given, you just key in into your calculator, and then you just scroll along the graph to look for the maximum point. Okay, if you are using the graphic calculator. But let's say if I do manually, then it will be like this. You do differentiation, dy dx, differentiate it, then let dy dx equal to 0. Then you solve and find x. Then the mode is the x. So just like that. Okay. So if the graph is where you can see a maximum point, then that will be the way. Do differentiation to find a stationary point, and then you find the x. But sometimes your graph is like this, you know. Sometimes your graph is like this. Then you cannot use dy dx equal to 0 anymore. Okay, so what to do is, if your graph is like this, you just key in the function into your graphing calculator, then you see your graph to be like this. Then the maximum point is here. You cannot use dy dx one because at this point the dy dx is not 0 yet. Dy dx equal to 0 means the graph is having a gradient of tangent which is horizontal. But this one is not. This one, the gradient is still going up. The gradient is positive, it's not 0 yet. So that's why this method is not working sometimes. It works when there is a maximum point where the gradient of tangent is horizontal. If the graph is like this method doesn't work. What to do is you just key in the graph, the function, key in the fx into your calculator, or you just draw it, if the function is easy, just draw it out. Like let's say if a straight line or a simple curve, just draw out. After you draw out, if you see this is the highest point, then the mode is here. The mode is here. Okay. So draw the graph, look for the highest point, then the x value is the mode. So just like that. Okay. So sometimes your graph is like this. And then the mode is here. The highest point is there, and then the mode is here. Okay, so we look at the graph to determine where's the mode. The mode is always the highest point in the graph. Okay, now let's see. Next part, mean, mu. Integrate from 0 to 10. 0 to 10, they are referring to this 0 to 10 x fx dx. Okay, so that is the way to find the mean in general. They don't give the function, so in general we just do like this. Okay, now this part is how to find the median. How to find the median. Okay, median. You have mean, mode, median, right? So median. This M stands for median. The idea of median is where the median will separate the area into 0.5 on the left of median and 0.5 on the right of median. Something like this. Let's say if your graph is like this, total area is 1. This is what we discussed already. So median, let's say here, it will separate the graph into half and half on both sides. So before M, the probability is 1/2. After M, the probability is also 1/2. Only median can do this. Mean and mode, not necessary, but depends on. So median, they can always do something like this. Separate the area into half. So that's why in the note, this note is based on this graph. So they set the median to be here. Q2 is the median. Q2. Okay. We have Q1, Q2, Q3. Q1 is first quartile. First quartile is like 1/4. Quarter is 1/4. So third quartile, Q3. So we have first quartile, second quartile is median, and then third quartile. So we have three terms. Q1, Q2, Q3. Okay, so we start with Q1. You start with median first, Q2. Based on this graph, right? When you integrate from the smallest x value, 0, to median is Q2, then the area covered is here. Okay, here, this particular area, and the area is 0.5. 0.5. And they also try to explain it in the other way. If you integrate from Q2, the median, all the way to the right, the maximum x value, 10. So Q2 to, median to 10, the area on the right is also 0.5. It's also 0.5. So you can put it in this way lah, in general. In general, if you have a graph A, median B, 1/2, 1/2. So we have to know that you integrate from A to median, the area is 1/2, which is this area. If you integrate from median to B, it is also 1/2, but we are using this median. We are using this area. Okay, so you can do left hand side or right hand side. It's up to you, so depends on which function is easier to take it. Okay, so let's say one example. I use this. I have complete information to work out median. This is our working. So I have fx. I already found A. I have the complete function. I already find mean. I also show how to find variance already up to here. So already show how to find variance. So now I'm going to use this example again to show you how to find the median, as well as the mode lah. Let's find mode also lah, since mode is also in the syllabus. Okay, so lack of space. Okay, I put it up there. So this question, I copy the function again. Fx equal to 0, 1/6x. Otherwise 2 to 4. Okay, now I'm going to show you how to find mode as well as median. Okay, so mode first. Okay, let's say graph first. I draw the graph, then you can understand easily. This graph is easy to sketch, just a straight line graph. You see x is power 1, linear graph, straight line. So I put 2 inside, I get 2/6, 1/3. 2, 1/3. Now I put 4 inside, 4/6. 4/6 is 2/3. 2/3. Straight line graph. Where is the mode? Mode is the highest point of the graph. Yeah. Mode is 4. No need to use differentiation, you see, because the highest point is the graph, and we can see highest point easily if it's a straight line. Okay, highest point is just here. So the mode is there. Okay, how to find median then? You see, according to the concept, median will divide the area into half. Okay, let's say I show you in the picture first, in the graph first. Median, let's say here. Left hand side 1/2, the area. Right hand side, the area is also 1/2. So you want to use left hand side or right hand side? No problem. Let's say I use left hand side. Let's say okay, now I want to find median. Integrate 2 to median, 1/6x is 1/2. That is how we do it. We want to find median, so we continue this. 1 over 6 x squared over 2 to m 1 over 2. Okay, then I substitute m squared over 12 minus with 2 square 4 over 12 1 over 3 equal to 1 over 2. M squared over 12 equal to 1 over 2 plus 1 over 3, 5 over 6. M squared equal to 5 over 6 times 12, 10. M equal to 3.16. Okay, so you see when we get this answer, right? Should we take positive or should we take negative? You see your graph. Your median is in between 2 and 4. So of course it must be a positive value. So because of that, median is 3.16. 3.16. Okay, so that is how it works to find out the median. You can also use right hand side, like what I said. You can use right hand side. You can integrate from median to 4. So let's say you can integrate from median to 4. 1 over 6 x dx is still equal to 1 over 2 because it represents area on the right, which is also 1 over 2. And if you see the working here, x squared over 2 4m 1 over 2. Okay, so 4 square 16 over 12. 16 over 12 is 4 over 3 minus m squared over 12 equal to 1 over 2. So 4 over 3 minus 1 over 2, 5 over 6, m squared over 12 times 12. So m squared equal to 10. So end up with the same answer as you can see here. Okay, no matter you take the left hand side of the median or right hand side of the median, it works. Okay, so this is the simple example on how to find mode and median. But sometimes it will be harder. Let's say one more example. If I use this one cannot use, this one is invalid one. Okay, so this one okay, can use. Okay, so I use this. If there are two functions here, two rules, how to find mode, how to find median. So let's take a look. Okay, so I'm going to bring down this thing. I sketch the graph first. A graph will help you to imagine, then you can understand better on what happened here. When x is 2, I'm going to substitute 2 into this function. 2 over 6, which is 1 over 3. 1 over 3. Yeah. When I substitute 3 inside, I get 1 over 2. Okay, then quadratic. I substitute 3 inside. I get 9 over 56. 9 over 56, 0.16. 0.16. Okay, 0.16 is somewhere here, lower. 0.16. Now I substitute 5 inside. substitute 5 inside, 25 over 56. 25 over 56, 0.44. Okay, so 0.44. So I just bring the value to the side and label it. Just now this one is 9 over 56. Okay, 9 over 56. One over 3, 9 over 56. Now this value 25 over 56. Okay, so that 1 over 2 add up a bit. One over 2. Okay, so that is my graph. 2 pieces of graph. How to find mode? Again, mode is the highest point. Highest point is here. 1 over 2, right? Highest. This one not even 1 over 2. It's not even 0.5 yet. This one 0.4 something only. So highest point is here. So the mode is 3. The mode is 3. We can't even use differentiation because they don't show the maximum point like the normal situation. So we can see the maximum point from here. So mode is 3. Median. When you want to find median, there is a problem. The problem is we don't know yet. Either the median is in the first interval or the second interval. We don't know where is it. Not like just now, just now one function only, very simple very easy to determine. Only one function, only one interval, median is in between. Now you have 2 interval. Okay, so you have 2 interval, 2 to 3, 3 to 5. So where is median? We can determine in this way. You just find out the area on this part, and you may also find out the area on this part. Then from there you can determine one. Okay, let's see. I find out the okay, so I call it check the interval that contains median. I had to check first. If there are 2 functions, 2 intervals, I had to check where is the median stay. Okay, so I am going to find out the area for the first graph, 2 to 3. My function is 1 over 6x. 1 over 6x. So become 1 over 6 x squared over 2. Two to 3. Substitute 9 over 12. 9 over 12, 3 over 4. Substitute 2. 4 over 2, 2 over 6, 1 over 3. 3 over 4 minus 1 over 3. Okay, so the area that I get is 5 over 12. So you imagine this area is 5 over 12. The other area no need to find one. We know straight away. 1 minus 5 over 12. 7 over 12. So where is median? Remember the characteristics of median, where it divides the area into half on the left and half on the right. That is the idea of median. Half means 6 over 12. 6 over 12 is half. So here it covers 5 over 12. So median should cover another 1 over 12. So median should be here to cover a little bit more. So that on the right hand side of the median, the area is 1 over 2 or 6 over 12. On the left hand side, it is 5 over 12 plus 1 over 12, which is 6 over 12. So the median is there. So by finding the area and analyze using the concept where medians break down the area into half on each side, then you know median is there. So median is hence in 3 to 5. So now how to find median? If you use the left hand side of the median to find, you are troubling yourself. Because if you use left hand side, you need to integrate 2 to 3. Not too trouble actually. 1 over 6 x dx plus 3 to m. The second function is what again? 1 over 56 x squared. 1 over 56 x squared dx equal to 1 over 2. Like that. Then you have to solve and find median. Okay, compare first. If you are using right hand side of median to find the area, median to 5, right hand side only one function, which is 1 over 56 x squared dx equal to half. So I prefer the right hand side one. The left hand side still working, not too bad, because this one I know the area already, 5 over 12. So let's say I put inside 5 over 12. This one I know already. Then x cubed over 3 times 56, 168, 3m, 1 over 2. Then you just need to solve m cubed over 168 minus 27 over 168, 9 over 56 equal to 1 over 12 plus 9 over 56 times 168, m cubed equal to 41, m equal to cube root 3.4, 3.45. 3.45 reasonable or not? Reasonable lah, I see. Should be around 3 to 5, right? Based on our analysis, 3 to 5. Now you get 3.45. Reasonable. Okay. You can also use this. So the working will be like this. Integrate x cubed over 168. 5 to m equal to 1 over 2. Substitute 5. 125 over 168. 125 over 168. M cubed over 168 equal to 1 over 2. And then minus 1 over 2 times 168. M cubed equal to 41. So m equal to 3.45. So there are two methods to be used to find the m, the median. So either left hand side of the graph, it involves two functions, or right hand side of the graph, it involves only one function. So you already know how to find mode and median. Okay, now you see they say prefer to use this, not necessary one, depends on graph one. Okay, this one works also. This is left hand side of median, this is right hand side of median. Okay, so I put a mark here first. We discuss until median. first quartile and third quartile haven't yet, so I leave it for next time lah.